So I guess I'm going to start.
Okay.
In the slides, I'm probably going to end up reading a lot of speaker notes, but then I'll take a little minute to kind of go over what may be on the slide or address any questions that people may have regarding that. And due to the nature of setting up Hadoop, I'm going to start by launching the cluster so that it's ready for us when we need to do anything. Okay, good, terminated. So we will name the cluster Hadoop Meetup. Actually, going to make a separate S3 for logs because it seems like a good idea. All right. Hadoop Meetup.
It's taken.
It's taken. You'd be that guy.
Random number.
Yeah. Hadoop Meetup.
2016.
Bucket. That was a bad decision. Hadoop Meet.
Oh, bastard.
Both redundant naming with a typo. Wow. All right, first hurdle's passed now. So I'm just creating a logs folder to dump all of the Hadoop logs. And then I'm just going to have a data directory, I guess. So I'm going to put all the logs in there. So, Hadoop logs. We're going to be using core Hadoop, so that just has the services that we're using today. We're going to be focusing on Hive and Hue. I'll go into what those are a little bit later, but on the surface, it's a web interface to interact with Hadoop, and the other one is it's reminiscent of a database. We have another person.
Yes, sir.
Hey, how you doing?
Come on in. You missed the intro.
Oh, no worries. I struggled to make an S3 bucket.
We had some technical difficulties at the beginning.
So I'm going to make these compute nodes so that this goes a little bit faster. And we'll do 3 unless we want to do more than 3. Has no effect.
It's your thing.
I'll do 3.
Okay.
Do 5. No. Okay, so it's creating.
So what's that doing then? Is it creating all
I'm creating the Hadoop
components?
cluster now. So I just made one name node and 2 data nodes. And it's currently installing the core packages, which would be, it's doing an HDFS layer. I'm going to explain most of this later. And then it's doing MapReduce, Hive, Hue, and I don't know what else is in the initial offering, but that's just kind of like the core Hadoop, just for basic functionality there. Awesome. So Hadoop. Hadoop is supposed to solve big problems and be simple, but it's not really simple. It's a little bit of a pain to set up. So it has a bit of a cult following, but third-party companies are kind of making it easier every day, like Amazon. We have Cloudera, we have Hortonworks. They all kind of make like a sort of more of a plug-and-play for Hadoop. Through like Elastic MapReduce. Like I just launched a Hadoop cluster. I don't need to be like a Java developer to be able to like tie all these nodes together. So they're making it a little bit easier. And now to read my speaker notes. Hadoop is fundamentally infrastructure software for storing and processing large data sets. It's an open source project under Apache from Yahoo and has become very popular as of late. To understand Hadoop, you really need to know the 2 core concepts, and that is how you store the data, which is an HDFS, and how it processes the data, which is MapReduce. MapReduce kind of processes it in a very unique way. versus the traditional architecture that we currently use, like with server, with either like a SAN or just local storage or whatever you do for current architecture. So for one, let's pretend you had a really large file. So let's say you had a 250 gig file, but your server only has 180 gigs. You couldn't store that one file on the server. So with Hadoop, you could through having multiple servers, and you would shard that data. So you could then, instead of having the 180 gig file, you would have 3 data nodes, and you could do 60 gigs, 60 gigs, 60 gigs. So that's a more of a distributed manner that would look similar to that. And I guess to explain what the name node is and the data node, I should probably take a step back on that. The name node stores all the metadata. So it kind of stores where certain data blocks are in the data nodes and all the permissions for all of these files. So you can kind of think of it like file permissions, like the NTFS, kind of like who can write, who can, and where these are, where these data blocks reside on what servers. An example of this, of the one server having like a file that's too large to store. I was trying to do create the demo, and I downloaded a rather large file. I tried to extract it, but ran out of room on my server. This was 8 gigs. But I launched 3 node Hadoop cluster, and I just ingested that into HDFS, and it sharded it for me, and it worked. So, of course, it's through servers that could hold it versus the one, but it's a good way to use distributed computing and have everything kind of like up front. So, with traditional architecture, I guess I'll go back that route. You have the software here, and you have the data here. So you kind of, with what we have to do today, you kind of move the data over to the software, and that can be over like a network. That could be probably over the network, and if that's a large data file, that can take a long time, and that can just saturate the line. It can cause any kind of connectivity issues, but primarily it can take a long time. So the unique thing that is with Hadoop is it brings the software over to the data. So that's what MapReduce does. It kind of gets what the application is supposed to do, and it shards it into like 4 different essentially queries for whatever kind of answer you're trying to get. So instead of having to get this 240 gig file over to a single processor, over to a single computer for it to analyze this data, you then have 4 different computers working on an equal amount of the data, so it's 4 times as fast, and also relatively highly available. So there's several different phases with what I'm showing you right now. I should explain is the MapReduce phases. So I made a little bit of a scenario up of, I'm sure you've read it by now, but Jim has a chip shop and he sells a lot of chips. These numbers are in millions because it makes it a more exciting example and bigger data. So the way that it's working right here is this would be like the ingest. So this is like his log files of he sold ketchup chips, barbecue chips, dill pickle, barbecue, and it goes and it splits that up. So it gets the first 4 chunks. This is moving the software to the data. So it gets the first software to the data, then you have the barbecue, dill, ketchup, and it moves the second and third. And then what it does is it does a shuffle and it reorganizes the data into a relatively logical format, and then it reduces it. So that's the map reduce. And then what it does from that is it returns your results. So then you have that as your ingest, you write a MapReduce job, and you get that as your answer. So he sold 12 million bags of chips. Good for him.
It's a lot of chips.
It is. 2,160 metric tons of chips, assuming the bag was 180 grams. I did the math. I seriously did. I also did the math on how big the file would be by there's 8 bits in a byte, how many characters I used, and I calculated how big the file would be. So Hadoop has some really strange naming conventions.
We need you.
Yeah. So I don't know if we actually went over there. So Hadoop, the founder of Hadoop is Doug Cutter, and he actually named Hadoop after his child's stuffed elephant. His name was Hadoop. So from that, they kind of spawned the the zoo animals of Hadoop. So at first we have Hadoop. Here's the elephant. Next we have Hue and Hive. So I'm going to go back to my speaker notes because I totally abandoned them in the last slide. So Hue and Hive, if you like SQL, you'll be happy to hear that you can write SQL, and Hive will then convert that SQL into a MapReduce job. So we kind of just saw an example of how that architecture works. Hue will give you a browser-based interface to do your Hive work. We'll see this today. That's going to be in the example. I'm going to be doing that exact part. There's also a bunch of different tools that Hue gives you access to, which would be HBase, Pig, Scoop. There's a lot of lingos here, but there's a wide array of tools that you can use from within Hue, which is a tool that Hadoop can use. Pig is the next one. Pig's a high-level programming environment where you can write MapReduce jobs. The language that you write in is called Pig Latin. And it has very unconventional names, but you get really good price performance with Pig. Apparently, I don't actually know that. And I have a couple more pictures, so I'm going to go through them all. This one's Zookeeper. So what he does is he synchronizes all of the zoo animals. So you're about to meet 2 more zoo animals, but he kind of keeps everyone in check, kind of like a sync. So I think I had a witty phrase here. He's used to synchronize the tools you're using in Hadoop for the cluster. You won't be working with a zookeeper, but he'll be working hard for you. So he's kind of behind the scenes and makes everything sync and work together. The next 2 are Impala and Mahout. Mahout is for machine learning. So in traditional machine learning algorithms, they're very linear and they can't be scaled out due to the nature of what they do. I have something here. Many pre-existing algorithms in machine learning are intrinsically non-scalable. Given the types of operations they perform, they cannot be executed as a set of parallel processes. But the algorithms in the Mahout library are able to be distributed. So it has a very specific set of machine learning libraries that it can be done in a distributed fashion. Impala is, I should give a little bit more of a history on traditional Hadoop before I do Impala. So when Hadoop was designed, it was sort of, I think it was primarily Google's way of, they're searching the entire internet and trying to index it and give you a nice search engine. But they weren't monetized yet, so they didn't have a lot of money. So they're trying to come up with a way to do this with commodity hardware, but lots of it. So they came up with this sort of method. So what Hadoop was, I guess, a couple of years ago is it was kind of a batch processing environment. So if you wanted an answer now, it's not really the tool you wanted to use, but if you wanted to do something at the end of every night with a bunch of big files, or you needed some month-end reports running, this would do that for you. But with recent inventions, more tools that have come out. Impala, which is this nice blue ram looking Impala creature. I guess I'm circling that on my own screen. There we go. So that gives you, I think I mentioned it to you earlier, but that's the data warehousing kind of tool. It does real-time synchronous SQL queries. So Impala was inspired by Google papers on Dremel. The purpose is to facilitate real-time querying of data in HDFS, which is the underlying file structure we talked about, or HBase. Impala uses a SQL-like language similar to Hive, which we'll be using today. Impala relies on Hive, therefore they must be installed together. So they need to be packaged together in the Hadoop cluster in order for you to use Impala. And it actually circumvents MapReduce, which is actually slow but distributed, to give it a throughput that's similar to commercial RDBMSs. So hop on the Hadoop train. We have Pig riding Hadoop. Any questions yet?
How long did it take you to make that?
2.5 minutes.
So
I know it's probably a little bit all over the place here, but it'll tie it in.
why would I use, and I'm going to screw up the words already, so Impala is sort of new?
Yes.
So why would I use something other than Impala? Is there a good use case to use the old method?
Like Hive?
Like is Hive like the standard map reducer?
Hive is slow. So if you wanted to run a single query, like look up table, like date this cell, it's going to take you like 20 seconds to get that. But if you wanted to parse through 500 gig table, do a word count, throw up the word count, and then do like prime numbers or I don't know, something that's more difficult, it's still probably just going to take you like 21 seconds. So it's slow for a single query. Like I said, it's not good for real time, but it's batch. So Hive is, you should have never used Hadoop historically for a real-time database.
So Hive would have been what you used to do batch processing, like Jim's Chip Shop, once a day.
Yes.
And Impala is more real time.
Yes. Impala it's sub-second response time looking up queries. Yeah.
Meetup was, I guess, was translation of some machine learning algorithms to be more parallelized.
Yes.
And I'm just wondering, can you characterize the kinds of algorithms for which Hadoop works better? Like, because like the
I can,
there's
but
things
continue.
you can't parallelize.
Right.
And so, do you have any rough ideas as to how to sort of characterize those two classes?
I don't. I think that there's just, is someone knocking?
Yeah.
Oh.
Go ahead, keep going.
So I think that it's just there's just a set library in Mahout, and these are all of the tried, tested, and true machine learning techniques, and they only have the library of the distributed ones. I don't know if there's certain like naming that you're looking. I'm not sure. It's not my forte. I just kind of was introducing Hadoop or
Not so
Mahout.
much for machine learning, but I mean in general. Like, so for example, like the give your chalk example.
Yeah.
Like that's something which clearly is arbitrarily parallelizable.
Sure. Yeah.
But there's other problems for which you just can't parallelize them. No matter what you do, it's not parallelizable.
Yeah.
So, like as a programmer, how would I know what I can and can't parallelize? Is there any kind
Well,
of
I would think like if you have a single server, you can't really parallelize. That's a hard word to say. Parallelize the machine learning on that because there's a single source.
Right.
But if you have a distributed framework and you're using Mahout, it can machine learn on all of the distributed learning. I don't know if there's a name for that or anything like that, but it totally depends on the source. And I think this more focuses on the actual algorithms it provides, but I don't know in greater detail of that. Okay, so I drew the slide myself. I was pointing that out. You can probably tell by my terrible lines. So this is how HDFS actually stores data. So by default, there's a replication of three times. So think of like a mirror, but more than that, but also not really a mirror. So we broke the word Amazon up into 3 different blocks. In Hadoop, blocks are typically 128 megabytes, but can be larger. So just pretend that this is not actually Amazon, it's representative. So we're going to break down these 3 blocks, and it's going to go in the name node. There's now a job to push this into its file structure, HDFS. So we have block 1, 2, and 3 here, block 2, 3, 1, 3, 1, 2. So there's a triplicate of data. So if any one of these nodes goes down, it's okay. Because like if we kill this one, we still have 1, 2, and 3 everywhere else.
So it's like RAID.
Sure, but it's better.
How does it decide? How does it break it up over the different nodes?
That's what it does. That's what it is.
It's kind of like load balancing in a way. Like
Yeah. So it's also rack aware. So if this was in your own data center and this was rack 1, 2, 3, 4, you could have it so that there's a better distribution. So you don't have, if there's like 6 servers here, it doesn't want all the data in one rack. So it will know to actually push it to different racks in case, like Anthony, he was let in our server room for some reason, and when he's walking, he trips over the power cord going into this rack, and then all of this data would then be gone. But since it's rack aware, it's okay. So we can let people like him into our data center. So when he trips, everything's still live. There's going to be a little bit of degraded service, but it will intelligently start replicating the data that's missing from here into the rest of the cluster.
So another question. A couple of years ago, we were talking about, I guess, the more AWS type sort of bare metal type stuff, so to speak, right?
Yeah.
And over there, you're also talking about replication and all these things.
Yeah.
Like for different regions, et cetera, et cetera.
Yeah.
So how does that lower level replication or backup play with this?
I'm not sure how they do it. Because in their data center, it can't be rack aware because you're not rack aware.
Okay.
That's something that you put in the configuration files. Like you would actually know which host names are what. Those are the data nodes. These are in rack 1. In Amazon, you can't do that. I'm not sure how they do it.
Like in a way, it seems like if you were, for example, suppose you could probably tune this, right? So you can have like each shard and like 3 or 4 or 10, whatever you want.
Yeah.
But
There's preferences, yeah.
Yeah, right. But if you did that, and if you also had like your server in like 5 different regions, and if you're super paranoid, right? Then actually you're having probably way more backup than you actually need.
Yeah.
And so if you is this more meant for people who just want to have like everything in a single data center, like single place?
It needs to be in one region. So this can't actually span multiple regions. It can span multiple availability zones within a region, but this can't go. You can't have a single Hadoop cluster, at least to my knowledge, that's sitting both in US East and US West. They're just introduce way too much latency, and it would kind of defeat a lot of the purpose.
Right.
Did that answer that question?
Yeah.
More or less. Okay.
And you can afford to do only one server, right?
Well, you can set the replication. You can set a minimum of 2, they suggest. If you do 1, then you're just asking for trouble. How often does a hard drive break in a laptop? Now imagine 4 hard drives per server, 20 servers. One of those is going to go pretty soon. So you want to have some fault tolerance built in there. By default, it's 3. It lets you do 2. You get a warning if you do 1, and I think you can do like up to 10 or something like that. But that's just a lot of wasted space.
Or sorry, is that what we're talking about, the cluster?
Yeah, in one cluster. I'm talking about the data replication. So by default, it's 3. So if we ingested the Amazon data, there'll be a copy of each block 3 times within that cluster.
Okay.
And clusters, I didn't mention this, but clusters can span anywhere from, I guess, 1, but you said Microsoft should do 1 Hadoop. Typically 3, all the way up to, I think Yahoo's is 42,000 servers. Yeah, that's it. But it can parallelize like just petabytes of data. It just goes through it real quickly. I mean, if you have thousands of servers and you want thousands of servers to work on your problems at the same time, why wouldn't you do that? Why would you want individual jobs working on each server versus like all the brain power working all the time on different problems? I mean, it's just I guess, more efficient way to do that. So I actually got a picture of Anthony, and I put it in here to show you what would happen if you went into our data center. So as for the example of someone tripping over the data center, so we have Anthony coming in here, and he actually shoots a flaming arrow, and he hits one of our data nodes. So in this example, we see that block 1 and 2 are now damaged. That rack was just set on fire. But as you can see, there's still 1 and 2 on data nodes. 2, but I guess they're not named, but 2 and 3, and it's also there. So even if the fire, this is a replication of 3. So even if the fire spread, just due to his negligence, he didn't get a fire extinguisher, we can still read the Amazon data. Even if it didn't spread there, but this guy shot another arrow, we can still read the data, 1, 2, and 3. So it's very available. And if servers go down, if parts of the clusters go down, racks go down, it's still, all of your data is intact, so long as it's configured correctly.
Grade 6.
Okay. So this was sort of more of a filler on my part for if you had any questions at this point. I guess we just kind of went through a bunch of questions.
Yeah.
I'm actually going to jump out of this real quick because I need to do something here. Oh, this is going to be hard with my screen like this. So I need to find my mouse. We're going to add a step. I'm going to refresh this, make sure it's launched. It's deceiving. I think it is done. So we're going to add a Hive step. So I mentioned the Hive program a couple of times. So luckily I have a pre-baked script. And what this is going to do is it's going to pull a CloudFront log, CloudFront log from wherever that location is, from the location that's coming up. And earlier we made, before you were here, we made a bucket. So I'm going to put the logs into that bucket for the output of data. Soft choice Hadoop, data deer. So it's running the Hive program. It's this script, which I don't have an example of right now, unfortunately. And it's getting the CloudFront log. So what it's going to do is make a table in Hive, and it's also going to provide a file for us in S3 with all the operating systems that are hitting our CloudFront distribution. But it takes a minute or two to run. So back here.
So then right now, when that's running,
Yeah.
it's splitting that CloudFront log across the members of our
3 servers.
cluster.
Yeah, when I go to hardware and I actually see the master instance, we can go into Hue, which runs on port 8888. So we're going to call this Hadoop, and so we'd see in the Metastore CloudFront log, so the job's already done. And I believe that I should be able to click on this. It's loading. Maybe it's not done. And here's a sample of all of our data that Hive step just did. So this just made that table with all this data. There should be a lot more data than that. It's likely still running. So the next step of our demo is actually the whole demo, unfortunately. Is we're going to go to query editors. I mentioned Hive earlier and Pig. So I could write a Pig thing here, but I don't know Pig Latin, unfortunately. So I'm going to go back to Hive, which is the SQL-esque kind of program here. And we're going to be running this query. So it's going to be looking up for the browsers now instead of the operating system. I have an S3 log. So actually, if we go back to S3 and we go into the data dir, we should see a file, OS requests. So I could download this. Call it X so I can open it easily. Didn't open on either screen. I didn't want to open it with regular Notepad. So this is the file that was in S3. So in that Hive job, one of the things was to output all of the operating systems and dump that into a data directory in S3. That was where I put it as that was the output. So there was the three. One was the script, one was the log it was parsing, and then one was the output. So a second step that was in that script was to create that table that we just looked at. So now, Alt-Tab is easier than finding my mouse. Oh, I need to find it anyways. So we go back to Hive, and when I run this, it's going to...
Is a bullet point for the select?
Pardon?
The bullet point for the select?
What if I had to troubleshoot when I hit execute? So now it's gonna show you a log as to what's happening with MapReduce. So you're gonna see step-by-step sort of, it's gonna go way too quickly, but you're gonna see how long it takes to run a single SQL query and why it was typically batch and why you wouldn't want it for an interactive SQL. So right now it's sharding up that data, it's bringing the software to the data, it's kind of writing that and checking out all the different data nodes. And it's just going through its stages: map, shuffle, reduce, results. So this would be a very painful experience if you're just trying to do a quick lookup. What's order number 532? And like, oh, I'll tell you in 1 minute. So it's sort of the abstracted nature as to why this takes so long, but I tried to do a different big data example for this with more data, because I could have done this with like a several gigabyte file and it would have taken a very similar amount of time. So it's really just MapReduce doing what it does. Are you guys able to see that, by the way?
Yeah.
Okay. Yeah. So it's done. It took all that time to do a couple thousand counts. So, we've had people on Chrome, Firefox, IE. I don't even know what Lynx is. That's interesting. Opera and Safari. So these are the people who have visited our CloudFront distribution. So that's,
People prefer links.
I don't know what the,
I used it about 10 years ago.
Yeah.
Yeah,
me too.
same here.
Yeah.
It was quick when it was slow.
sounds exciting. So that's the demo. That was the demo. I tried to download a bunch of data from Yelp, and I was going to do this thing where I could show you all these like cool reviews and process, because that was a bigger file. It was 8.5 gigs. But I couldn't pull it off in time.
Didn't work.
Not really. So this is kind of, I didn't hit present yet. This is just representative of the features that MapReduce have. I guess it's simple. I don't know why it's simple, but it's very scalable. So it kind of functions in that distributed fashion. So I kind of mentioned earlier, if you have 100 servers, why wouldn't you want 100 servers working on the problem at the same time? Instead of having that 500 gig file or 200 gig raw file, it's better to just break that into 20 chunks of 10 gigs and have like 20 different computers working on it. It's a lot faster to be able to parallelize the processing, parallelize. So that kind of goes hand in hand with the speed involved with this. I told you an example of recovery, which is if he tripped over the rack, it does a smart kind of a ping, almost like a keep alive on all of the data, and it would detect that data wasn't reachable, and it knows it's supposed to have 3 replications of data, so it would create that data wherever there's additional space. So in that way, it's recovery. And the minimal data motion is just not, as a broken record now, but not moving that huge chunk of data to the software, but bring the software to all the data. So that is the minimal data motion.
So in regards to recovery, you can add nodes whenever you want to.
You can add data nodes whenever you want to. So there's a name node. There's actually something called a secondary name node, but it's a very deceiving name. It kind of sounds like if the name node crashes, that you'll be able to use a secondary name node, but it can't. It just kind of does a backup of the store and has like a delta on it. So the name node can use the secondary name node, I believe, to sort of do a semi backup. If you're trying to do like an HDFS upgrade and the data kind of goes kaput, you can actually do a rollback. And that's through the help of the secondary name node. It's not actually a secondary name node, it's just terribly named. And that's actually it. So that's what is our demo in all the early stages. So that's all I got.
You mentioned data motion,
Yeah.
minimal data motion. So presumably that's minimal data motion after your setup phase, right? So
Yeah.
you can kind of think of this whole thing as being like a certain fixed cost and variable cost afterward, kind of a per query cost afterwards.
Yeah.
Right? So the question then is how big that first initial fixed cost is, right? So for example, you're talking about the Hive as being a very big fixed cost.
Yeah.
And then kind of as low variable cost afterwards. So I'm just curious, can you talk more about the sort of the setup cost of Hadoop in general?
Well,
And where it
it's
starts to make sense?
sure. I struggle with that a little bit myself because, like, here at SoftChoice, let's say we have 1,000 different virtual machines. We'll say that there's 100 servers. We're using all of that. So in order for us to adopt Hadoop, if we needed like a 40 node cluster, we'd essentially need to buy 40 new servers. So I'm not actually sure right now where the sweet spot is and when you'd be able to start adopting it. It's almost like you need to be able to free up 5 servers, set up the name node, get the infrastructure going, get all the data nodes, install the relevant applications, do your proof of concept, make your one application work. Then you can decommission that server and you have your working server. And then it's sort of a pick up and go until you eventually have your full big data environment.
Maybe if you have a very large amount of data, then relevant, because if you process it sequentially, it's going to take forever.
Yeah.
And you'd have a very big server with lots of storage, and there's limits on how big servers can get. The other thing is in most data centers, it's server hardware, whereas Hadoop ideally would be using commodity hardware.
Yeah.
So it's something more or less from scratch.
Yeah.
You have a lot of data and you got to parallel process it.
Yeah. Yeah. So if you're using Impala and you have 10 commodity hardware servers, that could be something that's comparable to like a giant Oracle database that's going to cost you ridiculous amount of money. So in that sense, it's worth it to move immediately, so long as it actually all the queries will work the same. You hit the same. Like I'm not a database administrator. I'm not sure, but so long as all the fine tuning will work, it's worth it very rapidly. For how cheap hardware is now and how everything's more or less licensing fees, adopting something like big data with its open source and free, it's just you'll start seeing savings immediately so long as it's like an appropriate application, which I'm still trying to get around. Like I'm not sure what kind of workloads at this point, like would you tie, like we could, if you're using like a database backend and you're constantly like writing to it, you could put that into Hadoop, but then you just have your application writing, like doing queries to Hadoop to get that data. So it's at that point, it's nice to have the database there. It's highly available at that point, but it's more about now, can you move that application into Hadoop? But it's like a homebrew application, so then you have to get into rewriting it, and that's a difficult part for me. That's what I'm trying to get at next is when and how you could start really using it in everyday business versus always being big data. I think there's a lot of big data methodology that can be used for a lot of small compute as well. That's what I like.
Fundamentally, we are the world's making lots and lots of data all the time. So much data, I mean, I don't, but like banks, or like if you were analyzing all the sales for all of say Walmart worldwide, you'd have a lot of data, and very hard to make sense of it.
Yeah.
So and I think the databases niche is maybe hot data, where it's a limited data set, and something you want a quick result on, and it's structured.
Yeah.
And then the Hadoop will be for large amounts. So over time you take data out of the database because it's expensive, and you've got all this archive. You've got maybe 10, 20, 30 years of data, and you've got so much stuff there, and you do need to look at it occasionally. I think it's also the concept of a data lake, which is a lot of data. We don't know what's in there, but it's a lot of data. So
and we shouldn't get rid of it. Yeah.
but we have to somehow filter it and sift through it, because there is stuff in there we need, and that's where you could potentially you could have that, and then you use your Hadoop on it to break it down into something more manageable. You put that into your database, and then you run your queries against your database, because then it's manageable and you can get something out of it reasonably quickly. So maybe.
Yeah, so I'm glad you said the word structured data, because I forgot to mention something, is that Hadoop can store both structured data and unstructured data, and through different queries you can actually run like a sanitize, and you can do queries of both the unstructured data and structured data at the same time, but you do need to do like some pig Latin in there to make it work. I don't particularly know how to do that, but I do have a friend who works with big data, and that's a huge draw apparently for a lot of people, is you can store your unstructured data and your structured data in the same place, and you can just kind of use it all. Kind of like also what you were saying is it's all commodity hardware. Like it's not like it's super expensive to hold all this data in your database. So you can store the unstructured data there, sanitize it, then you have your clean structured data, and it's all in the same place. So that was another point.
So how much would this little cluster that you built that's got 3 machines in it?
Yeah.
What would that cost per hour on Amazon?
Well, it's in Amazon.
What's that?
It's in Amazon.
No, but how much would it cost?
I think it's $1.06 per hour.
For each node or total?
Total for 3 compute nodes. So there's that's only 12 gigs of memory, because I did the compute, which is half memory for the size. But it has a lot of compute, so it does the MapReduce a little bit faster. That's why I did it. With the series, it would have taken probably another like 4 or 5 seconds to get the MapReduce job out.
But at a lower price, because it's just.
No, it's the same price. It was 10 cents more expensive to do the M4, but then we'd have 24 gigs of memory. And I could have made those disks a terabyte each, and it would have been relatively cheap as well. And then you get really good IOPS performance as well in Amazon. The way that they structure it with 3 IOPS per gig, we would have been looking at like a lot of IOPS. 9,000. So. Yeah.
Does that cost is obviously going to scale per processor? Does it also scale per kind of inter-processor communication as well?
How do you mean? Like the actual network between them kind of thing? Like,
Yeah,
there is obviously a saturation point with a 10 gigabit LAN, which I think Amazon's using as their backbone. So unless it's far more talkative than that, I don't foresee any issues. But I imagine if you did have Yahoo's cluster of 42,000 nodes doing heavy compute,
Right.
that
Yeah.
you're going to want to even localize within big data Hadoop. Like it's distributed, but probably like containerized distribution.
Mhm.
I'm not sure. They probably get paid a lot of money to come up with that stuff. So
Do you have any ideas of the kinds of, like aside from people, like other sort of categories of applications people are thinking about that would be sub Yahoo size?
So most of it I see would be banks as a big one. There's a lot of like threat detection. So if you are constantly analyzing this data, you can very quickly find out if someone's committing fraud or something like that. So let's say that Brett goes to an airport and he bumps into Payman. And Payman, just being the complete hooligan he bumps into Brett and he actually scanned his visa and he just got a copy of his visa. So he's now going to fly out to Chicago and you're going to go fly out to Virginia. You guys both land. You're going to go to a conference. You decide that you want a coffee in the morning. You go to Starbucks. You buy your coffee, and you go to
Best Buy.
You go to Best Buy and you buy yourself a large screen TV in Virginia. And
And
now knowing
Yeah.
that there's only one card that was issued, and if it's constantly analyzing this data with big data streams, it can detect now he's here and he's here. Something's wrong. So because they can detect it so quickly with something like big data, Brett's going to get a call. Hey, did you just buy a large screen TV? He'll be like, yeah, but I didn't buy a coffee, or vice versa. And it's through things like big data that they can constantly analyze all of the information they have coming in. Because as you said, there's just so much data now. There's so many different ways to collect it. People don't even know what to do with it. That's one of the more recent, I think within like 4 or 5 years, that they started doing things like if you're in 2 places at once, you can't be. So, they'll freeze your card and call you or something like that. Another one is just storage of big data for like medical warehousing, just because it's very highly available. And then
Insurance, I'm guessing they will use it.
I don't know about insurance. I'm sure there's so many applications. Like I'm sure Tesla probably uses it to like make their self-driving better. It's constantly doing analytics and sending that data over the air. Mainly analytics, I find. I don't know any like small jobs where I know where there's like startups that are using big data to do these small kind of.
Can you attach a CloudWatch or any of those that could show you how much stress your servers are going through?
Sure. So there's a lot of different web interfaces. There's like if you use Cloudera, there's the Cloudera Manager with Hortonworks. There's Anbari, and with Amazon Elastic MapReduce, there's just that dashboard that you see. And you can kind of see how stressed out each of the servers are. You see the distribution load. You can see how all the disks are doing, what kind of network traffic there is. So you can kind of check.
And can you modify it, or whatever you said in the beginning? It's what
You
you're working on?
can totally modify it. You can do whatever you want to do.
With
It
no
just depends
downtime?
how. Yeah, because it's you can take a server offline and there's no downtime. That's the beauty of having a triplicate of data on a large set of on a large cluster of servers. Is you can turn 2 down. You don't move them, but you could do whatever you want to do. Replace the hard drives or something.
Are there tools for like taking, for example, an existing program or algorithm and sort of translating the key parts of it to like?
So there's something like that for databases called Scoop, where it will ingest the entire database and kind of make a synchronous copy. I'm not sure about if there's a program that will translate your program into a usable Hadoop It's a bit of a stretch, I think, right now, but maybe in a few years. There might be. I'm just not aware of it at this point. That'd be pretty cool, though.
Cool stuff.
Yeah, so that was it. Hadoop.
Can you control the speed of that?
Yeah.
Thanks, man. That was really good.
Thank you.
Yeah.
Thank you.
Did you want it faster or slower?
So it's like, where's the wanted to grab a big giant data set?
Yelp.
Yelp. Do you have any other examples of stuff? Like, was there anything else you found?
Someone I know told me that you can actually just get some from Amazon. He told me that.
I knew that. I was trying to think of other things that maybe you'd seen
Oh.
while you were getting ready to do this, if there were other things like Yelp that you'd found.
I did, but I couldn't think of any intuitive ways where I'd want to write like for the example. I was really set on doing the sort of the Hive example, so you can see the MapReduce through the web browser.
Yeah.
I couldn't find anywhere I'd want to like be able to write a SQL query for it to like view some data for it. I just found Yelp. There was Amazon. I think there was something about weather. There was like a weather network one, but it wasn't actually weather network.
Okay.
It was one of the ones that pretends they're weather network.
I googled the Yelp one.
Yeah.
It looks pretty cool, actually.
Yeah.
2.2 million reviews, 77,000 businesses, 500,000 attributes about the businesses that are there, like hours, parking, ambiance.
Yeah.
It'd be pretty cool.
Is that in like some particular area or just across?
It doesn't
Wherever
say
there,
here.
there's, I downloaded that data set. There's GPS coordinates too. Like you can make a phone app that what are the 5 coolest restaurants around me, and it could sample 20 restaurants and give you the 5 that were rated the coolest that are open now. And you could probably set filters, and there's a lot of cool applications of what you could do with the data they gave out.
So why are they sharing it?
They shared it as for school. It was for education, and they were giving out a scholarship for whoever made the best application for it.
Oh, I see.
But it's still available, and they're just like, okay, take it. So yeah. But that was all I found. I didn't find like a lot of free large samples of data. I really wanted to find like a 300 gig file and just slam it and be like, watch it go.
Yeah.
But
I bet there are big size data sets of that size.
Yeah.
If you were to-
There must be.
well, I mean, there's definitely one you could get like a what is it called? When you're a rainbow table. So we could have generated a rainbow table and then like a word count on it or something. So that would have been like a 2 terabyte file if you wanted to. So
Would that be the same as an n-gram corpus?
I don't know what an
I don't know what that
corpus is.
It says I was looking at some big data sets in Amazon, and
Yeah.
they have a Google Books n-grams, a data set containing Google Books n-grams corpuses.
I'm not sure. A
wonder
rainbow
if that's
table
like-
would be like a brute force kind of like you
I
do
like
a bunch
grabbing
of-
all the most common words or something. Is that
Yeah,
what that does?
so what it does is it gives you frequencies of all single words,
Yeah.
and then of all word pairs, word triples, and so forth.
Yeah.
And you use that for like translations or language modeling and stuff like that.
Cool.
Hmm.
Thanks, man.
Yeah.
It's good.
Thank you. Did you guys all learn at least one thing?
Yeah, I'm trying to.
Not
think
to
of
let
something
Anthony in a
can-
data center?
Yeah, well,
Sorry for picking on you.
With a bow and arrow.
Yeah. I
Flaming
didn't
bow
know
and
you were an
arrow.
archery. It's pretty cool.
So did you like have some kind of embarrassing accident that some time ago that you're?
No, so the issue was I used him in the first example and I was going to use him in the second example, but I forgot that I made the slide where there's someone who did exactly what I said Anthony did, so I just used you again.
Awesome.
First name Robin, last name Hood.
Yeah. Yeah, I'm definitely looking into. I'm still limited in what I know about big data, but it's definitely something that's kind of growing as a hobby of mine. So I did want to do some really cool stuff. So like a lot of the new tools that are coming out, there's one called Spark. So you saw what Hive was doing, splitting out a MapReduce job is a little slow. It has to go to all the different servers, and it kind of just writes to the disk, and then you're limited by the disk and network I/O. You'll still be limited to network I/O for Spark, but it's actually sitting in memory. So you have a lot of memory-heavy servers. So in all of your data nodes, let's say they all have like 20 terabytes. That's great. So now you have like 100 terabytes of data, but they all may have some unused memory if they're memory heavy as well. So let's say you have 100 gigabytes of memory. Now you can load a 100 gig file into memory, and you can just like, pardon my language, you can query the shit out of that. So because it's really quick. So like you can do a lot of really quick things. So people were at first were like, oh, Hadoop's kind of slow. But like, no, they're making like some crazy changes, and just the application that's going to be available in the coming years is going to be crazy.
So one of the conferences that I went to, they were talking about using Apache Spark with Kinesis.
Yeah.
And I was like, what the hell is Apache
Yeah.
Spark? So now I get it. It's kind of like
It's a big data tool.
HANA, right? Where everything's in memory.
I don't know what HANA is, but now I do, I guess.
SAP HANA.
Oh, all right.
You have a sense of like what scale like makes sense to go from using kind of
Yeah.
analytics as a service to do your own, go on your own?
It totally depends what you want to do. I'm not sure. I would probably, just because I like it, do it for a really small example and start inappropriately. But I don't know at what stage is a proper stage to adopt big data at this point. With the cloud, do it whenever you want. I mean, it's $1 an hour. So if you're going to get in trouble at work for spending $400 or something a month,
Yeah.
I mean, just you're working on a POC to save us money. Like, I mean, I'm trying, guys. So,
But really, it seems like here your biggest cost is more the coding versus the hardware for a certain kind of jobs.
Yeah.
At least upfront.
yeah. So there's a big thing here that I've kind of avoided. Sort of the elephant in the room.
Wow.
So it's writing MapReduce jobs. That can still be very difficult. So if you do want to do something that's not just like a lookup or analytics, but you actually want to build your own application in Hadoop that does its own unique things, it can be difficult. And you basically need someone that can be like a full stack developer that probably knows Java, and that will be able to pick up Pig to be able to do it. But there are new tools as well. This is all a little bit older stuff. It's kind of teaching you guys core Hadoop. Never mind. So they have tools now where you can do C++, Python, and you can actually write MapReduce jobs with those. So it's Python, so he might try it. I'll have to let you know what tool it is. But it's getting easier every day. It really is. And with Cloudera, Hortonworks, and Amazon just kind of pushing this, I won't be surprised if they release Spark as a service soon. Like the way that they just kind of get all these crazy compute, and they're like, we offer that as a service now. It's easy. Just load your data and it's stored in memory.
Yeah.
So it's an exciting future.
Is there anything else big any of you guys see coming in the next 5 years? So, like sort of on general big data side?
Quantum computing.
Yeah, right.
I don't know, I kind of think with like this Internet of Things stuff, right? Like all the data that they're going to be collecting off of all these devices.
Yeah.
Like that to me seems like a logical way to find value in a giant pool of data that unless you can have some jobs running on it to analyze what it actually is.
Yeah.
And that could be anything, right? Like we were at that Silicon Hall thing the other day, and they were talking about sensors in garbage cans to notify
My old company did that.
notify people when they're full. And then like the garbage dude like has a little app, and he's just like, oh, I gotta go to this park and empty it. Like I would imagine like, you know, an application to analyze that data once you've collected a lot of it, to know maybe where you need more garbage cans and where you need less.
Yeah.
Maybe that's like a
So
job
at my
like this.
previous place, this was in 2011, they kind of did a bit of a big data job for doing garbage pickup. So this was over in, I think it was Winnipeg. What they do is the city gives out one garbage can per household, and if you need a second one, you need to buy it. You're not allowed to use bags. It has to be, you use this garbage can. It might not be Winnipeg, could have been just somewhere over there.
Same thing in Toronto.
Yeah, so they have an RFID per garbage can. That's associated to your address. And when the machine when the truck picks up your garbage, it actually uses an arm instead of a guy, and it kind of like pours in the garbage, and there's a camera, and it's viewing that data, so it knows what you're throwing in the garbage. So it knows if you're throwing things in the garbage that you're not supposed to through doing big data analytics, and it also knows, hey, you actually.
That's scary.
It also knows that your garbage wasn't out on the curb. We drove by it. Here's a picture of your house with your address. Your RFID tag wasn't out. So it also, hey, the garbage skipped my house, but really you didn't put it out in time or something. So there's just huge applications like that with garbage of all things. So there's definitely, yeah. I'm waiting for them to do it with streetlights. How many times do people stop for no reason because there's no cars going that way to just accelerate and go again?
Oh, like stoplights.
Yeah.
Oh, I was thinking you mean like street lights on the street, like.
No, traffic lights.
Traffic lights.
I guess like if you're going like 80 and you stop and there's no cars and you're like, I just lost so much, like it bugs me for some reason, but like fuel efficiency, environment, wear and tear on my car, like why did I stop? Because it's the law. Why is it like it's just stupid lights, that's why. Yeah. Fight the system. Yeah. If government's slow to adopt, like last I heard, I know someone who works for like Toronto government, like their healthcare, they aren't even doing virtual machines yet. They still have physical, like 200 different servers in the server.
Monolithic server.
Yeah. They're getting into a lot of trouble with like when something fails.
Yeah.
It still uses fax too.
It's what?
Fax machines.
Yeah. Because they have to go to the lowest bidder, and the lowest bidder is not changing.
That's a huge problem. I mean, I'm actually looking for a government worldwide that's front running, that's sort of leading instead of following. So far,
I know they do a lot of stuff in the U.S. Like they do a lot of, there's like a Code for America,
yeah,
right? Like they do some pretty cool stuff.
yeah.
But like around here, getting data even to analyze is hard.
Yeah, there's a lot of nice open data projects in the United States. You've shown me, like, you're limited to, like, doing trees here.
Still pretty neat, but.
Yeah, it was cool. I learned what kind of tree I have.
Practical example